VP of Engineering at Open Infrastructure Foundation, and Nauman Vavda, CEO and founder of iVolve Technologies. We're going to talk about Openstack public cloud implementation. Although the public cloud market is mostly dominated by hyperscalers, using cloud services from AWS, Azure, or Google in some parts of the world is challenging due to local regulations, digital sovereignty concerns, and latency issues. As a result, many businesses have started implementing their own public cloud infrastructure based on OpenStack to offer cloud services on local markets. If you have any questions as we progress through the webinar, feel free to raise them through the question box at any time. There will be a Q&A session at the end of this webinar, but you can put your questions in advance. You don't necessarily have to wait until the end of the webinar. If you raise your questions early, we'll be able to prioritize them. We are going to navigate through the following topics. We will start by pointing out the challenges organizations face when trying to use hyperscalers in some parts of the world. Then we will move to OpenStack and demonstrate how OpenStack can be used for the purpose of public cloud infrastructure implementation. Later, our special guest speaker, Mr. Nauman Vavda, will share some more details about their particular use case with using OpenStack at iVolve Technologies. Next, we will introduce you to Charmed OpenStack and demonstrate how Charmed OpenStack enables organizations to decrease the total cost of ownership of cloud infrastructure maintenance and, as a result, offer their services to their customers at a better price than hyperscalers. And finally, we will summarize the webinar with some key takeaways and open an interactive Q&A session. And now, at this point, I'm going to hand it over to Thierry, who will introduce us to the topic. Thierry, the floor is yours.
Thank you, Titus. So, hyperscale clouds are the well-known industry giants like Amazon Web Services, Microsoft Azure, or Google Cloud. And those hyperscale clouds have a number of benefits. And the most obvious of which is in the qualifier hyperscale. Those clouds have, at least in theory, an infinite capacity. That allows you to scale up to extremely large deployments should you ever need it. Another benefit from those hyperscaler clouds is that beyond the basic infrastructure primitives like raw compute, network, and storage, they generally have a lot of higher level services beyond those basic infrastructure primitives, like managed databases, function as a service, Kubernetes clusters as a service, etc. That makes it easier to build complex applications that rely on those higher level services. The third benefit of hyperscaler clouds is that they are well-known brand names, which attracted a large ecosystem of tools. Basically, when a tool works with clouds, it is extremely likely that it supports Amazon Web Services. Beyond those undeniable benefits, hyperscalers also have a number of drawbacks. The first one is the other side of the higher level services coin, lock-in. When you make use of higher level services at one of the hyperscalers, you basically get locked into their implementation or combination of services. Like, for example, if you use Lambda functions that leverage Route 43 and S3 services, that application will not be portable anywhere else. The second drawback is cost. It's a myth that the hyperscalers are cheap. They're actually more expensive than most other public clouds. They leverage that lock-in I just talked about into making you pay extremely high profit margins. AWS is actually the only profitable business of Amazon, and it serves to fund their expansion to other markets. The third drawback is distance. If you have low latency needs or live in a country with limited outside connectivity, if you don't have a hyperscaler data center locally, you're out of luck. If there isn't a huge market there for the hyperscaler, they will never come. Beyond that, for anyone not in the United States, the fact that all those hyperscalers are in the US or in China is creating a data sovereignty concern. Those countries can compel the provider to give them access to your data, and US laws apply. In case of geopolitical tensions, your critical data could be held hostage. Is that a risk businesses should take? Taking a step further back, relying on a couple of hyperscale providers means we face the risk of creating monopolies or cartels that ultimately reduce the pace of innovation and drive prices up. This is not really something anyone should encourage. And even beyond that market risk, the concentration of services into a few providers creates a risk of monoculture, where we create an internet that is not resilient in the face of failure. We have seen through recent outages how much of our everyday lives can be impacted by an outage at one of those hyperscalers. As more and more services migrate to the public cloud, if we rely on only a couple of hyperscalers, we'll end up with a very brittle system, the complete opposite of what internet was designed for. For all those challenges, we need alternatives to hyperscalers. And I like to think that Openstack public clouds are the solution. Openstack is an open source project that was created back in 2010. Back then, AWS was really the only public cloud game in town. People considered its API a de facto standard. There were a few open core solutions to emulate AWS in a private setting, but really no truly open source solution to build a public cloud from scratch. That is when OpenStack was created, to offer an alternative. The great thing is that it combined two separate projects. One coming out of Rackspace Hosting, bringing the requirements of public cloud providers, and one coming out of NASA, bringing the requirements of massive research compute private clouds. That is why OpenStack was, from day zero, built to serve the public cloud use case. Today, OpenStack is a collection of interoperable components that let you compose and build infrastructure as a service. The core services are around compute, networking, and storage primitives, but it also includes a few higher level services. It was very quickly highly successful in the private cloud space, and it now is a well-supported brand with a lot of tooling supporting it, much like hyperscaler clouds. On the public cloud side, we saw more and more adoption, up to now a total footprint of 78 data centers in 67 different locations around the world. We discover more and more OpenStack public clouds every day. Those have a large number of benefits. First and foremost, for users, the people that use those public clouds. Having a lot of smaller providers implementing the same technology rather than one big company results in an absence of lock-in. You can more easily switch from an OpenStack public cloud to another OpenStack public cloud that provides better services or pricing. You can also get lower latencies by using a local public cloud in one of those 67 locations around the world. You can pick a provider that is run by a European company to make sure local laws apply and your data cannot be held hostage in some geopolitical conflict. You get a healthy market of smaller actors that can specialize in narrow use cases like GPUs or ARM or gaming clouds, giving you the exact service you're looking for, rather than wait and pray for a giant hyperscaler to care about your use case. Thinking about the traditional key benefits of hyperscaler clouds, the famous infinite capacity, you can get infinite capacity without the lock-in drawbacks through interoperability across multiple OpenStack clouds. And finally, you can get an evolutionary path to hybrid usage by implementing a local OpenStack private cloud that will run the exact same code as the public cloud you use. This is essential to control cost once your application growth starts to stabilize. Okay, so absence of locking through interoperability, low latency through local deployments, data sovereignty through local companies, a healthy market of smaller actors, infinite elasticity through multi-OpenStack cloud, and truly hybrid evolution path with OpenStack private clouds. Those are all key benefits for users. But there are also benefits for the infrastructure provider, the people who deploy those public cloud services. The first benefit is obvious. You don't have to write your own tooling from scratch. OpenStack is stable, developed by a community of thousands of contributors. There is really no need to waste time and money reinventing that wheel. That, in turn, means you can control cost. But you can also rely on the OpenStack driver ecosystem to enable the hardware that best fits your use case. We have drivers for a lot of different types of hardware, storage, networking, and computing capabilities. You can also expand those services freely. The Apache license the code is licensed under allows permissionless innovation on top of the platform. And last but not least, by choosing OpenStack for your public cloud, you join the Open Infra community, a community of operators, of like-minded infrastructure providers sharing their knowledge at the Open Infrastructure Foundation events. You're not alone, you're on a path well traveled. All right, I hope I made a compelling argument of why we need OpenStack public clouds alongside the hyperscalers to solve the hyperscaler challenges. But it's time for a case study now. So back to you, Titus.
Thank you, Thierry, for a great introduction to the webinar. And you're absolutely right. We're going to move to the case study now. And here I'm going to welcome our special guest speaker, Mr. Nauman Vavda, the CEO and founder of iVolve Technologies. Welcome, Nauman. So for those viewers who are not familiar with the entire OpenStack community, could you please briefly describe what does iVolve do and what is our relationship? What is your relationship with both Canonical and the Open Infrastructure Foundation?
Sure. Thank you, Titus. So I'll start with brief introduction to OpenStack, as some of our audience may not have heard about it. So OpenStack is a cloud platform which is built by a global community of more than 70,000 individuals, and it's increasing across 180 countries, supported by the Open Infrastructure Foundation. iVolve has been delivering and managing OpenStack Cloud since its inception in 2016. Our relationship with Canonical is more of a strategic in nature, as we leverage its career-grade distribution of OpenStack, including the automation, deployment, security patching, and other support services when it comes to delivering critical private and public cloud installations. iVolve is also a silver member of Open Infrastructure Foundation. The foundation vision is to provide most advanced tool and platform for infrastructure operators, and it hosts many other projects besides OpenStack.
That's super interesting. And what types of services does iVolve offer?
So basically, iVolve is offering not just OpenStack implementation, but rather we have developed a 360 view around the services that our customers typically require in building and planning and operating OpenStack clouds. Our primary focus has been around OpenStack Cloud, designing, planning, and building and testing, benchmarking, securing, and managing services. We help many CSPs or cloud service providers to build and offer infrastructure as a service and compete against hyperscalers successfully. We also help our customers in achieving different kind of regulatory and compliance requirements, which are very critical to regional cloud players. These can be standard PCI DSS, ISO 27001, SOC 2, CSA level 2, GDPR, and other regional compliances. Not just that, we also have our own SOC from where we provide 24 by 7 security monitoring services as we understand the criticality and sensitivity of these infrastructures. iWorld has strong present practice around Kubernetes in designing, deployment, and managing Kubernetes and different solutions around platform that our customers require. We understand that once you have a cloud, there is the need of having a strong practice of providing migration services and disaster recovery services. So we help build such offerings for our CSP customers. We also help them with our services to migrate from any kind of environment to OpenStack Cloud and offer disaster recovery services to their customers. Very important aspect is that we have developed our own platform, which is called Cloud 7. And it is all around single engagement platform for our CSP and their customers, from where they will be able to manage and sell these services to their end customers.
Right, thank you. So among various cutting edge technologies, you still focus on OpenStack. Why?
Definitely. We have worked on several technologies, and there are some very important reasons that we have focused on OpenStack and helped our customers implement OpenStack. In a nutshell, if I would explain, one of the most important argument of CSPs to offer services to their customers in the cloud is to have the kind of flexibility and the scalability, because it may scale up to hundreds or thousands of nodes at times. With OpenStack, it is truly achievable. We can have a large, highly scalable infrastructure managed. Secondly, you can have vendor lock-in easily with other technologies, while with OpenStack, we can avoid such vendor lock-in issues. And it supports any kind of different kind of hardware, different kind of network infrastructure. Third reason would be that OpenStack is an API-driven cloud. So basically, you can program and use OpenStack in many different ways. Also, because OpenStack is an open platform, and there is so much innovation that is happening by the community. As I mentioned, that more than 70,000 people have contributed and are continuing to contribute. So the innovation is bringing a lot of options to the OpenStack operators and service providers. And this is one of the key strengths that, or a unique advantage towards using OpenStack compared to any other proprietary technology. Finally, the most important aspect is OpenStack Cloud can be a lot more effective and inexpensive when you compare with other proprietary technology. Building public cloud is usually considered to be a very expensive affair, but it has, we have with OpenStack a proven solution which is carrier grade and yet providing a highly cost efficient solution.
I think you're absolutely right. But on the other hand, like implementing a public cloud infrastructure based on OpenStack from scratch must be expensive too. How does it really relate to the pricing offered by hyperscalers?
Well, that's a very important point that you touched on. As I mentioned earlier, that building and operating OpenStack Cloud can be cost-effective provided we do it right. By that, what we really mean that we need to have right set of skills, or you need to have the right partner and effective deployment tools. All this augment with the right required planning. This is the key to the success. On the other hand, hyperscalers are not cheap, as you mentioned earlier in the discussion, that hyperscalers are not cost effective, and this is typically a myth. OpenStack can offer far better ROI when compared with hyperscaler cloud providers. This really, what it translates for CSP is that they can build very competitive offering using OpenStack.
I think you're absolutely right. And we share the same feelings here at Canonical. But is OpenStack really suitable for public cloud infrastructure implementation? So how do you handle things like billing, for example, which is a typical feature offered by hyperscalers?
Right. So we had a bit of a journey there. We started developing a product called Cloud 7. And Cloud 7 is a completely in-house developed product which we are now offering to our customers. It fully integrates into the OpenStack and gathers all the required information and utilization data to offer the billing and monetization. The end customer of CSP have the full self-service capability from where they can provision new services, manage complete life cycle of the cloud services. On the other hand, CSP can bill its customer on many different models such as pay-as-you-go or on-demand and other reserved models as well. Cloud 7 gathers all the logging and usage details from the OpenStack and the surrounding systems. So besides the pay-as-you-go on-demand, the CSP or cloud service provider may also choose to create packages or bundle based on many different conditions, such as the utilization or the volume of usage, such as the period of reservation of the service, and so on and so forth. It's not only a monetization platform, but rather a full management solution. It has a complete, like I said, self-service capability, a very comprehensive reporting system wherein the CSP have the detailed insight with the reports such as usage, revenue leakage, capacity reports. It has resource provisioning, quota, and user management engines as well. So Cloud 7 on top of OpenStack makes the wholesale public cloud solution for the CSPs.
Understood. And how about security and compliance?
In our experience around security, we have with Canonical already providing a hardened solution which is ready for many security standards. And we also have our own security practice which we use to provide customer the compliance, as I mentioned earlier, that our practice around the security and security team, we have the security, more of the security monitoring and also the security advisory service from which we help customer achieve these compliances as they require. And we implement different controls, encryption technologies, key management, secret management, and different identity solutions to help them achieve the compliances as it requires.
All right. But operating public cloud infrastructure based on OpenStack is definitely more challenging than operating a single node microcloud deployment, right? Like there are hundreds of nodes running over there. So how do you handle all of this complexity?
As you know that typically when we implement OpenStack, usually we're implementing on a quite large infrastructure. So the automation plays a very vital role. With Canonical, Metal as a Service, and Juju, it provides us the required automation tools for us to deploy at scale without really worrying about if it was only 10 or 20 nodes or hundreds of nodes. For us, it's really a much simpler job than people could imagine. So the complexities are really managed well if you have the right set of tools, such as what we use today.
All right. Perfect. Well, thank you very much, Nauman, for this amazing interview. I think it's always great to hear, like, from someone who's using OpenStack on daily basis in a variety of environments. So that was actually great. All right. So at this point, we're going to move towards the third part of the webinar, which is the introduction to Charmed OpenStack, which is Canonical's distribution for OpenStack. So let's jump straight over there. So Charmed OpenStack is an enterprise OpenStack distribution backed by Canonical that is engineered for the best price performance. It is a pure upstream OpenStack distribution that is based on components that are 100% open source. Charmed OpenStack uses the concept of OpenStack Charms, which are the officially registered project under the governance of the Open Infrastructure Foundation. Thus the name Charmed OpenStack. Using OpenStack charms for the purpose of OpenStack deployment and operations significantly reduces the time required to maintain the cloud. What's represented in the diagram on the right is a model of an OpenStack cloud that consists of charms. Contrary to other automation frameworks, charms enable so-called model-driven architecture, where more complex systems such as OpenStack can be modeled in a composable way. Like users can model the cloud according to their needs, and charms deploy the cloud accordingly. Similarly, users interact with the model rather than the cloud itself when making any changes post-deployment. For example, users can trigger the upgrade of the OpenStack cloud, and charms perform the entire procedure in a fully automated way. Such an approach allows to significantly reduce the TCO associated with OpenStack maintenance while leaving the space for increased innovation. And this is exactly what the mission of Charmed OpenStack is. Decrease the TCO while increasing the budget for innovation. If you have a look at the diagram below, it represents a typical IT budget for data center maintenance. It consists of 4 primary pillars. The first 3, hardware and facilities, software licenses and services, and internal operations and maintenance, have a negative impact on the business, like they represent the raw costs. Thus, decreasing this cost is essential. Now, using the model-driven architecture and charms, as mentioned in the previous slide, allows to significantly reduce the cost of internal operations and maintenance. Moreover, by providing an optimal architecture for OpenStack implementation and offering our services at an optimal price, Canonical truly helps to reduce the TCO associated with OpenStack maintenance while expanding the budget for innovation. Charmed OpenStack comes with a predictable release cadence that follows the upstream. This means that the new version of Charmed OpenStack is released twice a year within 2 weeks from the upstream release. Those are shipped with new versions of Ubuntu by default. However, since Canonical recommends using Ubuntu LTS in production environments, new versions of OpenStack are also available on Ubuntu LTS. OpenStack versions that are shipped on Ubuntu LTS by default, also known as OpenStack LTS versions, are supported by Canonical for 5 years. In turn, interim OpenStack versions are supported for 18 months. Enterprise customers can also extend their support for some interim OpenStack versions and subscribe to the Extended Security Maintenance Program for 10 years of security updates. Upgrades between consecutive OpenStack versions are fully supported. Users can first upgrade to a newer version of OpenStack until the next OpenStack LTS version, and then they can upgrade the underlying Ubuntu operating system. Charmed OpenStack also provides a high level of security. Users can benefit from up to 10 years of security updates under the Ubuntu Advantage for infrastructure subscription. Their data are encrypted both in flight with TLS and at rest with Cephe's building capabilities. Moreover, various hardening programs are available for enterprise customers according to CIS and DSAP benchmarks. All control plane services run in isolation inside of dedicated containers. Furthermore, the kernel live patch service enables updating the kernel of the underlying Ubuntu host OS without rebooting the node. And finally, Charmed OpenStack is compliant with various certification authorities, including Common Criteria, General Data Protection Regulation, and Health Insurance Portability and Accountability. When it comes to interoperability across various platforms, Charmed OpenStack supports all typical cloud architectures and leading hardware, SDN, and storage platforms. While hyperconverged architecture ensures the best economics, it is not an option for some organizations. In such cases, one can deploy Charmed OpenStack in a converged or fully disaggregated mode. The platform supports all leading CPU architectures and all hardware vendors that participate in the Ubuntu Hardware Certification Program. While open source SDN platforms such as OVS and OVN are deployed by default, Canonical also partners with Juniper and Cisco to provide support for their proprietary SDN solutions. And finally, on the storage front, while Ceph is the default option in the majority of the deployments, organizations also have the freedom to use Swift or iSCSI-based storage solutions whenever needed. And last but not least, Charmed OpenStack provides all typical enterprise features that are usually required for public cloud infrastructure implementation. The entire platform is highly available, ensuring the desired SLAs, both in the infrastructure and the tenant space. It also comes with an integrated observability stack for logging, monitoring, and alerting purposes that provides enterprise dashboards with aggregated logs, health, and capacity metrics. And finally, thanks to the TrillioVault add-on, Charmed OpenStack provides cloud-native backup and recovery capabilities for instances running on top of Charmed OpenStack. And now, since we're moving to the end of the webinar, let's briefly recap what we have learned. So first of all, due to bandwidth and latency limitations, digital sovereignty concerns, and local regulations, hyperscalers are not an option for organizations in all parts of the world. At the same time, OpenStack and the ecosystem around it provide all the necessary tools required to implement competitive public cloud infrastructure. Among various OpenStack distributions available on the market, Charmed OpenStack is an enterprise distribution engineered for price performance that is suitable for both public and private cloud infrastructure implementation. Proof of this is the case of iVolve, who became a leader in public and private cloud implementation in the Middle East and South Asia regions thanks to OpenStack. And that's pretty much all for today. We would like to thank you very much for your attention. In case you would like to learn more about Charmed OpenStack, I would like to invite you to visit our website at ubuntu.com/openstack. Similarly, if you would like to learn more about services offered by iVolve, please visit the website at ivolve.io. You can also use the contact form from the webinar attachments to reach out to us directly. And now, we will be more than happy to answer any questions that you may have. Thank you very much.
Thank you so much, presenters. That was super thorough and really informative. My name's Amber. I'm going to moderate this Q&A section. So before we start, I just wanted to cover a few logistics. The first being that this webinar is being recorded, and you'll receive the recording as soon as it's finished via email, so you can go through it and watch it at your own time. Additionally, we've attached attachments, the contact form that Titus mentioned, along with white papers, webinars, ungated, as part of the attachment section. So have a look through those. You're welcome to also add comments on anything else you'd like to see in the Q&A box, and we can upload those on demand. And finally, if you haven't submitted your question yet, please do. We've had a lot of good ones come in, but we'd love to be able to answer all of your questions that you might have. And I won't take up any more time from the Q&A section. So Titus, Thierry, are you ready for the first question?
Yes.
Sure, let's do it.
Okay, perfect. So the first question is, you mentioned that new OpenStack public clouds are created every day. What is driving that growth, and which geographies are they created in? Thierry, I think this one might be one for you.
Yes, when I said that we discover new OpenStack public clouds, it's currently mostly in the Europe region. I feel like it's driven by requirements around digital sovereignty. We're seeing a lot of new players coming in, or I would say like old players that are revealing that they are using OpenStack under the hood, which is also sometimes we don't really know that they're running OpenStack, but we discover it after some time. But they see more value in showing that they are using OpenStack and federate between other OpenStack public clouds. And it feels like it's also a result of that push for more digital sovereignty. But I expect that will actually happen in other geographies as we go. Since most of the hyperscalers are based in the US or China, I would see that growth happening in other non-China, non-US geographies.
And one now for you, Titus. I've heard Ubuntu has recently become the #1 operating system for OpenStack. Deployment, is it true for large-scale environments like public clouds as well, or only for development environments?
I guess this question might be coming from one of my recent blogs that was available at ubuntu.com/blog. So yes, according to the OpenStack user survey results from 2020, Ubuntu has become the most popular operating system for OpenStack deployments, but we unfortunately do not have any insights on the size of those environments. So those can be a mix of development environments and real production environments. Usually the survey is filled in by people who have an active OpenStack project in their organization. I believe around 80% of the environments overall have been reported as the production environments. So it is a mix, but it's hard to say where exactly those data are coming from.
Okay, great. And another question here is, for me to move from hyperscalers to OpenStack-based public cloud, the decisive factor is the cost per VM. What's the cost compared to hyperscalers when running OpenStack on Ubuntu? Titus.
Right, so that's a very good question, and I totally agree. So whenever people are considering a migration from one cloud platform to the other, in most of the cases, the driving factor is the overall economics. It is really hard to measure that when it comes to a private cloud compared to public clouds, which reference pricing is publicly available, and you can get like a cost per VM, cost per terabyte, cost per IOPS. All of those codes are publicly available, and there is a bunch of public cloud pricing calculators that are available, especially for the hyperscalers. So you can quickly get a cost estimate on how much it's going to cost you to run those workloads in a public cloud. In a private cloud, it's more tricky because it always depends on the scale of the environment, on the hardware being used, local hosting charges, operations costs, and so on. But we have a tool that allows us to provide our customers with cost estimates for running a shared OpenStack private or a public cloud based on the reference architecture. It is not available publicly yet, but if you want to get cost estimates for your environment, you can get in touch with us and we can provide you with those estimates.
Okay, great. And this next question could probably be answered by either of you, but how long has Canonical and Ubuntu been involved with OpenStack?
I can take that one. I was there. I would say it's been around since day zero, or even day -1, with a few people say, because a few of the people that worked on OpenStack at the start actually came from Canonical, and we imported a lot of the development principles that originated for Ubuntu into OpenStack, including having design summits the way Ubuntu did the Ubuntu developer summits. So having all the developers in the community come together to discuss openly the future of the platform was something that we imported from back then. And you can also see it with our time-based releases. The fact that we release on a predictable schedule is also something we imported from Ubuntu, and we're still doing.
Thank you. And someone here has asked, is there a location I can receive installation instructions?
Yes, there is a location. Well, I think the best place for OpenStack installation instructions is the official OpenStack documentation at openstack.org. But if you are looking for installation instructions on Ubuntu, specifically, all of them are available at ubuntu.com/openstack/install, and they cover like 3 scenarios, starting from a single node installation up to a large-scale installation, like for a public cloud infrastructure implementation.
Great, thank you. And the next question is, where can I find the more technical details on public cloud implementation using OpenStack?
Right, so I think it's a good question because this webinar was mostly focused on the business drivers behind implementing a public cloud infrastructure based on OpenStack compared to hyperscalers. So when it comes to the technical details, it does not really differ much whether you're deploying a private cloud based on OpenStack or whether this is a public cloud that's based on OpenStack. There may be some additional components that you could consider for public cloud implementation that you wouldn't consider when deploying a cloud on-prem for your internal purposes. But if you are looking for more technical details, then installation instructions page is one of your destinations. I'm pretty sure we can also include in the attachments for this webinar the reference architecture for charmed OpenStack implementation on Ubuntu that could help you navigate through all of the technical aspects of getting charmed OpenStack on Ubuntu up and running.
Yes, we definitely can. So if you check back in after this webinar's finished within about 10 minutes, I'll have that added in the attachment section for everyone to have a closer look at. Great, and the next question is there a way to integrate OpenStack with VMware?
So